Death sentence. Yes, promises, async await, and set timeout are not less than death sentence whenever they are asked in the interviews from developers. Cause in the simple ways these are nothing whenever they asked like in a separate way, but whenever these are combined or mixed, like the scenario of async await with the set timeout, scenario of promises with the set timeout and async await, whenever they are mingled and mixed up in the interviews, they are like time bomb and death sentence to the much of the developers. So in this video we are going to dissect in a detailed way, so these will be peas and nuts for the devs in the interviews in their next life. So let's jump into the video and start how to handle these properly. Okay, so first of all, like you have to have some idea of promises, async await, and set timeouts before starting the video, cause I am not gonna tell you what these things are basically, but I am going to lay down some scenarios in front of you how to handle in the in a much complex way. So, but okay, that's fine. Let me tell you in a little time what these things are actually. So, in a quick way. So, promises are nothing. Promises are just objects which contains resolvers and rejectors, or you can say in a analogy way, like these are workers. Whenever you assign some task to promise, it will either resolve or reject your task. So promises are your workers. So how you create them? These are actually behind the scene classes. So you define with the new keywords, and then you write the promise keyword and you give resolve and reject, and there is a callback, it accepts, and there is two arguments, reject and resolve, and you perform all of your operation whatever you want. And then if I show to you, there is also reject and resolve methods on the promise keyword, so you can also call them directly like this. So if we define a variable promise, and then we did promise dot reject on that, and if we do promise dot reject, then we have to call promise dot catch to catch out or like whatever the error or rejection this promise gave to us. Okay, so after calling rejection you have to call catch, and here you can do whatever you want to do in this callback function. And if you do resolve, then you have to call the then function or then method, and then it takes a callback as well, and you can do all of your operation in the resolve scenario. Okay, so this is in short what promise is, but actually this is a long concept. You have to have the idea of promises before watching this video. Okay, so that is it till that. So here you can see, if I simply reject and then catch, here you can see it prints out okay catch rejects, and then if I resolve and then I call then, it simply prints out okay resolve, and here on this line it's simply printing out hello. Okay, let's comment it out. This was a quick overview of promises. Okay, now let's move towards the actual stuff of the video. So I will start with the little simple code example, then we will make it complex, and I will also elaborate how these things happen behind the scene at the whiteboard as well. Okay, so first of all, let's see this example. Here we have a agile1 method function here, and this is asynchronous function, and it is an arrow function. Okay, we have the set timeout here of 8 milliseconds, and we are assigning this set timeout as a method to this variable a, and actually I am flagging out all of these bundle of statements as a variable, so I can explain these things better to you. So this is flagged, this all method is flagged as a, like this is assigned to a variable a, and then we call this method a here, and you can see like after 8 milliseconds console log a is being printed out. This is the simplest scenario. Okay, before jumping ahead, let me explain something at whiteboard so that you can have a better idea of the things how under the hood, like these are being handled. Okay, let me move toward our whiteboard. So if you didn't watch the previous video of fundamentals like asynchronous, concurrent, and non-blocking Node.js behaviors kind of things, then must watch it out, otherwise you will not be able to understand all of this video. Okay, in previous video we have mentioned like we have a call stack, main call stack of JS engine here where all of our code executes, and we have here our event loop, we have our micro task queue, and we have our callback and timer APIs of the browser. Okay, so our main code goes here. Our micro task queue has priority over callback queue, and this callback queue handles actually timer related callbacks and timer related functions and all of the functionalities which are related to set timeout, set time interval, and some of the other things. And this micro task queue handle all of the things related to asynchronous and promises thing. This empty queue handles promise related things, and this handles timer related things. There are many of the other functionalities which these queue perform, but for this video, in the context of this video, only this concept is enough. Okay, so this event loop continuously check this call stack, and if it finds some of the timer related functionalities like set timeout, it just pick this up from here and assign to this API. By the way, this is the API of browser for timer functions. Like it handles set timeout, it handles set time interval, it handles all of these functions. So what event loop does is it picks up the task set timeout method from here and just assign to this API, and whenever time like ticking up, and when time just finished, it will be assigned to this callback queue. It will be just put from this API to this callback queue, and then it will be whenever like this call stack will be empty, this task will be put again into the call stack. Okay, let me show you the example of our task. Okay, so as I mentioned, this micro task queue has priority over callback queue. What it means, the tasks which will be related to promises and async await, these tasks will be executed first. Like let's suppose we have a task 1A here and task B here. Okay, so first this task will be executed first instead of this. Like let's suppose we have A here and B here, and this B will be event loop will check this call stack, and B will be put here, and this A will be then put here. And you can say how empty queue has a priority over callback queue. This, whatever the scenario will be, even let's suppose if the timer of this is only like 8 milliseconds and this has 10 or 100 milliseconds, this will be resolved first. Empty queue has a priority cause fetch and promises and async await related calls will be handled by empty queue, and this has a priority over callback queue, and all of the function which will be, all of the task which will be in empty queue, it will be resolved first. Okay, so this is the thing that I want to mention first. Okay, so what will happen is let me remove it out. If you want to take screenshot, you can do, because I have to remove this some of the things. Okay, so what we did in our function, which I was elaborating to you, what we did there is like we have this method here agile which has set timeout, and we have assigned this set timeout to a variable A. Now this A is being treated out as a function. Now what happens is, whenever, now I will have these things side by side so you can see them properly. So now whenever execution context will reach at this line number 78, it will pick this agile1 method, and it will put this agile1 method from here into this call stack. So now what will happen, this agile one is residing here in the call stack. Okay, now execution context, our interpreter will now reach at this 79 line, and it will see like there is a set timeout, and it will do nothing cause we are not calling this a method, cause you can see this set timeout method is being assigned to this a, and this whenever this a method will be called at this line number 82, what will happen, this a method will be picked from this line 82 and will be put into this call stack again from here to here. Okay, now as we know, like event loop is continuously checking this call stack, like if there is anything, any task which is heavy, read heavy or write heavy, are kind of related to timing, so this event loop is continuously checking the call stack. So it will check like, hey, we find out there is a method a which is related to set timeout timer API, and this will block the main thread. This a will block this main execution thread of call stack. So event loop will pick this a method which is related to set timeout here, and this event loop will pick this a and will put it out into this timer API, and now this a is here residing for 8 milliseconds. Okay, now this a is being popped out from this call stack, so we can remove this a from here. And now as you know, this 82 line is executed now. Here 82 line is executed. Now we know that this agile one method has nothing to execute, and this is just ending at this 83 line. Okay, so this agile one method here in the call stack will also pop out from the call stack, and it will not reside in the call stack. So we just removed from the call stack this agile one method as well. So behind the scene, as we know, this timer is also ticking up. This timer is also ticking up here. And what will happen? Whenever this timer will be ended, this timer will be finished at 0 milliseconds. So now as timer ends, we know that this set timeout as timer ends here in the timer API, we know that this a method, or we can say this set timeout, simply has a callback here. Here you can see, here is the callback. This line indicates the callback. Now as the timer ends, so what will happen? This callback method will be pushed into this callback queue, which is residing here in the timer API. If I show you by just writing out, so here you can see, here we have set timeout, and here we have this callback function which is of 8 milliseconds. Now as timer ends, this only timer API picks up this only callback method, and it will be pushed into this callback queue. And now as we know, the call stack is empty now. So this callback queue has a callback method here which is containing console.log a, which is containing console log a. So this will be pushed into this callback queue, call stack, and this will be pushed into call stack, and finally the console log a will be printed out as a output. And whenever this line will be executed, it will be popped out from the call stack as well, and call stack will be empty. So at the end only we will see a as a output on our compiler or on our you can say code editor. So a will be output finally at the end. So as we have console a, so it will be printed out onto console, and this will also popped out from the call stack. It will be removed, or you can see popped out from the call stack. So this is what happening. And let's suppose we have let's take another example here on the stack blitz code editor, and then I will explain onto our whiteboard. So first of all, let's we are done with this agile one function, and now let's take another example. So let's now take the example of promise now. So here we have agile 2 initialization method declaration, and then we have another method here which is called out. Okay, and this out is containing this promise which is being returning from this line 88. This has this promise which is being returning from 88 line, and this promise consists of a set timeout again, which is of 5 seconds. And now let's make a timer a little less, of 10 seconds, okay, of 50 milliseconds. So, and this promise is being resolved inside this set timeout. So what will happen actually, whenever I will save this and you will see the output, what will be the output? What you think? Actually, we are calling this out method here, okay. So this will return promise to us. Let me have another variable for that and just call this promise here with the help of then. Okay, so now whenever we will call out here, this will return promise to us, and promise will be saved in this variable, and then we will call then on this promise, cause this is being resolved here. So you can see the console output in the right side here. Let me save it out, and you will see B being printed out here. And if I increase the timer here of 5 seconds, then you will see it will be print out 5 seconds, 2, 3, 4, 5, and you see B is in the console. Okay, so this is how promises are being dealt. But under the hood, how promises are being handled at the, like you can say call stack, event loop, how event loop is handling the promises. Now let me show you the whiteboard here. So let me raise some of the things and create our new function. So this is what I have created. Like this is the agile method we have of our recent example, and let me just clean out the stack as well. So here we have our agile method, and inside we have our out, and then inside we have our promise here, okay, and then we have our set timeout of 5 seconds. Okay, now whenever the execution context will reach here, it will just pick this agile method up and will put into this call stack as we like discussed earlier. And then whenever execution context will reach here at out, this out will be put into the call stack. And when this will be reached here at the promise level, so this, it will see like out is containing a promise in itself. So what event loop will do? Event loop will handle promise in a different way. It will not give promise to the it will not give promise to the timer API, but instead it will give this out function containing promise to this empty queue. And let's mark this as a out here. Okay, so now this empty queue has a priority over callback queue. It will quickly see and quickly see the function inside, what is the inside of out, and it will see there is a promise here, and inside the promise there is a set timeout here. There is a set timeout. Now what empty queue will do? Now micro task queue will pick the timer from here inside of out function and will assign it to the timer API now. Now it will assign it to the timer API of what, how many seconds? Of around 5 seconds. It will assign this set timeout to the timer API from this micro task queue, from this out function. And now this timer will wait here, and whenever the 5 seconds will be completed, what will happen? This out method will comes quickly, quickly comes here for a wait to be empty this all call stack. And as this out is just popped from this call stack to this empty queue, so that's why this call stack will be empty. So as this call stack will be empty, then at the end, whenever all the functions are just executed, our agile is executed, out is executed, the only one thing left is our timer API. So this will jump into this call stack and will console log what it will console log. It will simply console log what we are consoling, and it will console log like resolve B. So as we are set timeout is returning a resolving promise in a way to console B on the console log, and at the end it will simply put this out into this call stack, okay, into this call stack, and will simply console the B as we are like resolving this promise with the output of B, like here you can see. So this is what I want to show, like how promises and set timeout are being handled at behind the scenes, and how event loop is handling. Like promises are going to the empty queue and set timeout are being handled via callback queue. So now let's make it a little more complex. Now if I take the example of this function agile3 and make, now this is not asynchronous. Okay, we are not using async await. Of course the promises at the end are asynchronous, but we are not using async await here. So whenever we will call out dot then, as promise takes time to resolve, so first of all the execution context will reach at this line 101, okay, and it will wait for the promise to be resolved. It will do that? No, it will not do that. It will not wait for promise to be resolved, because it will let the execution context to go at the new line, because we are not using async await. Okay, so this promise will go to empty queue and will wait in the API, in the timer API, and right after this method, this console.c will be log out, and then after some time of 5 seconds this B will be console out. So let me save it and see the output. So see this, first of all this C just output, and then after 5 seconds there will be a B. Cause we are not using async await, so we are not like blocking this main thread. So the thread will quickly go to this line 110 and will console this C, and then after some time 5 seconds this B will be console out. You will understand this better in via below example. Let me just copy this, not copy, let me change this here as well. So if I just write async here and then just comment this down and put await here and then call this out here. So let me write a await here, and let's save this out into another variable out. Let's call it result, and then just console this out. Okay, so now if I save, now you will see after 5 seconds first B will be printed out, this line will be executed 110, and then 112 line will be executed. Why? Cause we put the await here and we are saying it, hey agile function, just await on this 109 line, and then execute all of the stuff which is later line at later lines. So this is how efficient async await is. Like you can stop your execution at some of the point and then you can resume at later point. So this is how async await with the help of SetTimeout works. So SetTimeout at the behind the scenes, like I have shown to you, like SetTimeout just goes to the timer API and then put into the callback queue, and like empty queue has a priority over callback queue, and empty queue just execute things first and then callback queue executes all of this stuff. Okay, this is the third example, and let's go to our next example, which is a little more complicated. This one. So this has SetTimeout. This has two SetTimeouts in it. This one, and then it has a promise, then it has a await, and then it has a another line at 130. Okay. So how this all scenario will work? Let me show you the whiteboard first and then we will console it out. Now what I have did is I have just picked that example of our code editor at here, our whiteboard, and this is the main entry point function, okay, agile, and then we have set timeout with 8 milliseconds timer, which is console A, and then we have B with the promise returning, and then set timeout and it resolves B and with the 50 milliseconds, and it is awaiting here, and then we have C here. Now I have marked different sections of this code snippet as, and this set timeout as A, and this section as B, and this section as C, so that like we can easily simulate how our things are going. So I will not put like this whole set timeout here, but instead of this I will only put A here, as this is being represented as A here. Okay, so first of all, what will happen? Let's start our execution. First of all, when execution context will reach here, agile will be put into the call stack, and I am not going to put it because we know it will happen. We don't want to clutter our whiteboard. Okay, let's move ahead. And whenever execution context will reach here, okay, at 117 line, this A will be put into the call stack. Okay, so let's put A into the call stack, and whenever this, let's have a loop here, event loop here as well, this event loop will check, oh, this A is related to timer. Okay, let's put this A into the timer now. So this A will be removed from here and will be put into the timer with 8 seconds. Okay, that's good. Now it will move ahead. The execution context will reach at 120 line. It will see and put into the call stack as B. Okay, so now it's just put into the call stack, and now what will happen? It will call, event loop will check like, oh, this is related to promise. Now let's quickly put this, remove this B from here and put into the empty queue. Now it is empty queue. This, we have a lock here, we have an await here, we have an await here because we are calling this B at this level. Okay, so whenever execution context will reach at 127 line, then it will be put into here, into the call stack. So as we have now, B is moved into the empty queue and we have await here, so that's why C will not be put into the call stack because we have await, and we say call stack, hey, just wait here, and whenever all the things will be just executed, then just put C into the call stack. Now do nothing, just wait. Okay, so execution context call stack will wait here, and what will happen? Actually, now we have a blocking effect. Now we are blocking our call stack. Now we are telling our call stack do nothing and just wait here. Okay, so what will happen now? B is in empty queue, micro task queue, and B is actually a promise, and micro task queue will see that like, oh, B contains timeout again, like B contain a timer of 50 seconds. Now what will happen, this timer will go into this timer API again as a B of 50 milliseconds. Okay, now it will go there and it will wait here in the timer API. So whenever this like MTQ has just, you can say, just resolve the promise, you can say, or after 50 seconds this promise will automatically resolve, as MTQ just put this into the timer. So after 50 seconds time, this promise will automatically be resolved, and as the time of this A method is less, so this is 8 seconds, it will be resolved first, and it will be just put into what, into this callback queue. Okay, this will be put into callback queue, and after that after 50 milliseconds this timer will be finished and promise will be resolved and will be put into callback queue as well, B. Now this A will go first into this. Now this await is just finished, await is finished. Now this A will go into again and will be popped. A will go into call stack and will be popped. Okay, and it will be print A onto console. Here is our console. A will be printed on console and it is just popped, and then B will go into call stack and it will be executed and popped, and it will be printed out here. And then as await is finished, now await is finished, now C will go into the call stack, as call stack is now empty. C will go into call stack and it will be also popped eventually and will be console out here on our console output. So this is how these things will go under the hood using micro task queue and callback queue. And let's just execute this thing on our code editor here. So if I just save this out, you can see ABC is being printed out. So if I just increase the timing here, it is 5 milliseconds, and if I do it as 5 seconds, now you will see it will wait here. A has a less timer, so it's resolved quickly, printed out here. Let me save again. Okay, A has less timer of 8 milliseconds, just resolved and printed. Then B will come here with 5 seconds, and then after that C will come here. So this is the good example to grab all of the concepts, combine. You can just rewind the section of whiteboard to see how these things were just going on. Okay, so now make it a little more interesting and more complex, and let's see what we got. Okay, so let me just comment out this now, and let's put our. So what I did is I have just removed this promise from inside of this agile function to outside and called it func, and this is residing now outside of agile, and this is being called here. And if you see what will happen, this is the same scenario. First set this set timeout will go and wait for 8 milliseconds. Then as this don't have time, now let's see what will happen. We don't have a timer here, we don't have a timer in the promise. So what will happen, this promise, okay, so let's start from the start. Whenever the execution will go to there, this line 145, it will put into the call stack. Then execution will go to this line 138, like execution context will go inside this agile method at 138 line. It will see it's a timer, it will put into the timer API. Then what will happen, it will go to this line. As soon as this method will be executed, this named func, it will print out B on the console, cause it has no timer and empty queue, microtask queue has a priority over callback queue. So it will quickly resolve this promise and it will be on the console. So as now await is just finished after finishing this function. So await is just vanished. Now C will go into the call stack, cause call stack is empty after execution of this function, and this set timeout is residing in the timer API. So call stack is now empty. So this C will go into the call stack and will be printed out on the console. Okay, so this C will be printed out on the console, and then whenever the set timeout will complete its time, then A will be printed out on the console. So let me save it, and here you can see the output. So let's tweak it a little bit. If I change the time here as a 0, then the output will be same. Here you can see. And why it is same? It should be in a way like first B, like first A, cause it has 0 timer, first A, then B of func, and then C. But no, it will be not ABC, but it will be the same B, C, A. Why? Cause whenever execution context will go here in the set timeout, it will put into the timer, and now it will execute after when all of the call stack will be empty. And when call stack will be empty, after the execution of this last line of this function. Whenever this last line 144 will be executed, then execution context will be empty, and then this set timer function of A will come into the picture. So this is how it is working BCA again. So now let's move to next example, which is a little simpler, and let me just comment it in and comment out it. Okay, so what will happen here? Now I have just separated this function as a outside of this agile. It is returning set timeout with 50 milliseconds, and it is returning this B. So if I save this, this is the console output which it is showing CA. And why this is not why this is not printing out this B? Because we are by the way, this is not promise. Now it is only set timeout. Now it is only set timeout, and it is returning something. So we have to save this out into a variable, and then we have to console this result. So if I save this, you can say it is just vanished. Why? Because we didn't put any console log here. So here you can see result is weird, 577, and then we have C and A here. Okay, and now let's have our next example. Let me comment it out, comment it in, and comment it out. Okay, so this is our next example. So if I saved it, you can see the output. Let me explain what's happening. Now we have this function, and we don't have promise here. We have only set timeout of 50 milliseconds, and this is the set time of 10, and then we have console C. So whenever execution will come at this point, this will be set into the timer API for 10 seconds. Then this await func will be executed, and it will be set for 50 milliseconds, and then C come into the picture. Now as this is not a promise, so it will go into the timer API for 50 seconds. This line, this function func will go into timer API for 50 milliseconds. Okay, and this is already in timer API for 10 seconds, and as call stack is empty, as both of these are into timer API, so this C will go into call stack and will console out first, and then this C, so first of all C will console out, then as set timeout this has timer of 10 less timer, then this A will come into picture, and then B will come into picture, cause this have to wait more than this set timeout. Okay, so this is all, and if you didn't get anything, just comment down. We'll clear it out. We'll have another video with some more complex topics and examples, and that is it for this video. If you just liked it, like it out and share and subscribe, and see you in the next video. Bye bye.